equations of motion tell how a system responds to an input. So in this case, the behavior is position, velocity, acceleration. Input, force, torque. Put angle in there. So basically, the equation of motion just relates the forces to the output. So we learned Newton had some equations of motion. He had some of the forces and some of the torques. So that was sum of the forces equals mass times acceleration. And sum of the torques equals moment of inertia times angular acceleration. Now, there's a different method that is related to energy, and that was invented by a guy named Lagrange. So that is kind of looks like d dt dl dq dot minus dl dq equals force or torque. So force if q is a position variable, okay, so he has this one for force, and then d dt del L del theta dot minus del L del theta equals torque. So this would be external force and torque. Now L is actually the energy function. So this is a scalar thing. L equals kinetic energy minus potential energy. And so it just happens that if you write the energy equation for a system and then you take its derivatives, then you can end up with the force or torque and see how the system behaves in response to that input. Now, how do you know how many equations of motion to write for a system? Well, we need one equation of motion for each degree of freedom. So the degree of freedom is the number of independent variables required to specify position. So that is how many coordinates you need. So if something's only moving in the x direction, then you only need one equation, x. If something is only rotating, then you only need one equation, theta. But if something is rotating and it's moving, then you would have to see, can you relate x and theta together? So we'll say example of this is if you have a wheel spinning, theta is its angle of rotation. So that is the degree of freedom of this system. Now, if you have a block that's moving along the ground, then x is its degree of freedom because it's moving in x direction. Now, if you have, say, a wheel rolling down the plane and it's going, say that's the x direction, but it's also rotating with theta. Well, there's still only 1 degree of freedom because x and theta are related. So if this radius is r, x equals r theta. So we still only need 1 equation of motion for that. Now, if it's something else, like let's say you have a hockey puck on a table. You're playing like air hockey. It could go like that. It could go like that. It could go like this. That is 2 degrees of freedom. You need an x and a y. So that is equations of motion. Now that we've learned Newton's method, now we're going to look at how do you do the Lagrange method.